Angle between two straight lines. That's the topic of this video. So first let's consider the vector form, where the acute angle between two straight lines R is equal to vector R is equal to A vector plus SB vector, and R vector is equal to C vector plus TD vector is same as that of the angle between B and D vectors. So let's consider this to be our vector A plus SB vector, let's say in this direction, and this in this direction. Let's define this as our C plus TD vector. Now let's consider this to be our vector B in this direction, and this to be our vector D in this direction. Okay, so we can see that A plus SB vector, since we have B here, so this line B vector will be parallel to this line here. Similarly, C vector plus TD vector will be parallel to vector D. So that's what we have here. Therefore, using the angle between B and D vector, we can say that it's the same as the angle between these two lines. So the angle between B and D vector will be cos theta is equal to B dot product with D magnitude divided by magnitude of B into magnitude of D, or we can say that theta is equal to cos inverse of this whole thing. Next, if let's say that the two lines are parallel, then what happens is our theta, which is the angle between them, should be equal to 0 because they are parallel. So if theta is equal to 0, then your cos theta will become 1. So when your cos theta is 1, which is this value is equal to 1, then the numerator is equal to the denominator. So you can say that in such a case that the magnitude of B dot product with D is equal to magnitude of B times magnitude of D. Next, let's consider the vector B to be B1 I cap plus B2 j cap plus B3 k cap, and vector D to be D1 I cap plus D2 j cap plus D3 k cap. Next, we can define B vector dot product with D vector as B1 D1 plus B1 D2 plus B3 D3 using the dot product formula. And also our magnitude of B can be defined as square root of B1 squared plus B2 squared plus B3 squared, and the magnitude of D can be defined as D1 squared plus D2 squared plus D3 squared. Now we have seen in the vector method that our angle theta is equal to cos inverse of B dot product with D divided by magnitude of B into magnitude of D, when the equations are, or the given lines are A plus SB and C vector plus TD, where B and D would be parallel to A, the first equation, second equation correspondingly. So let's use the Cartesian form now. So using the Cartesian form, if two lines are given in Cartesian form as this and this, where this would represent our first line, which is A plus SB vector. The reason being B vector is parallel to this, so we're going to divide them with B1, B2 and B3, which would be the direction ratio here. Similarly, for the second equation, we would divide D1, D2, D3, which would again be the direction ratios. So then the acute angle theta between the two given lines is given by substituting the values of B dot product with D from here into this formula. You get this, and substituting these values, these two values of magnitude of B and magnitude of D into the formula again, you get this. So this would be our Cartesian form of expressing the value of theta. Let's come up with some useful inferences. The two given lines with direction ratios b1, b2, b3 and d1, d2, d3. So you have two lines. The first one has direction ratios as b1, b2, b3 and the second one is d1, d2 and d3. These two lines are parallel if and only if the ratio b1 by d1 is equal to b2 by d2 and it's equal to b3 by d3. Similarly, the two given lines with direction ratios b1, b2, b3 and d1, d2, d3 are perpendicular if and only if our dot product b with d is equal to 0, which is b1, d1 plus b2, d2 plus b3, d3 is equal to 0. And if the direction cosines of two given straight lines are L1, M1, N1 and L2, M2, N2, then the angle between the two given straight lines can be cos theta is equal to magnitude of L1, L2 plus M1, M2 plus N1 and N2. Let's look at example 6.29. Find the acute angle between the lines or vectors equal to I cap plus 2j cap plus 4k cap plus t times 2I cap plus 2j cap plus k cap, and the straight line passing through the points 5, 1, 4 and 9, 2 and 12. Okay, now here in this case you're given two lines. This is the first line and you have a second line which passes through these 2 points. So if this is your first line, this line will be parallel to this 2I cap plus 2j cap plus k cap. If this is, a vector, then this line will be parallel to this vector here. And also these two points are given. A line that passes through these 2 points, if you subtract, the corresponding values, like 9 minus 5, which is 4, 2 minus 1, 1, and 12 minus 6 will be 8. So the result that you get will become the direction ratios for this line. So we can say for the first line, it is parallel to 2I cap plus 2j cap plus k cap, and the direction ratio of the straight line joining the 2 points 5, 1, 4, 9, 2 and 12, or subtracting 9 minus 5 is 4, 2 minus 1 is 1, 12 minus 8, 4 is 8. So this is our direction ratio, and hence this line is parallel to, using the direction ratios, we have a vector 4I cap plus j cap plus 8k cap. So this line which passes through these 2 points will be parallel to this vector here. So therefore the acute angle between the given 2 straight lines is theta is equal to, we know the formula, cos inverse of b dot product with d magnitude divided by magnitude of b into magnitude of d. And here our b and d are defined. B would be 2I cap plus 2j cap plus k cap. This will be our b, and our d would be 4I cap plus j cap plus 8k cap. So if you're going to substitute the values of these b1, b2 and b3 and d1, d2 and d3 into this place here, and you get this. So your final answer would be cos inverse of 2 by 3, which is the angle theta. Now let's look at the next example. Example 6.3. Find the acute angle between the straight lines given by this and this, and state whether they are parallel or perpendicular. Now, comparing our Cartesian equations of straight lines, which is expressed in this form, we see here that our b1 is 2, b2 is 1, b3 is minus 2, and d1 is 4, d2 is minus 4, and d3 is 2. So we know how to find cos theta now, or theta. So where our B1, B2, B3 are 2, 1 and minus 2, and D1, D2, D3 are 4, minus 4 and 2. Therefore, the acute angle between the two straight lines is theta is equal to cos inverse of magnitude of B dot product with D would be B1 D1 plus B2 D2 plus B3 D3. So that's this numerator divided by square root of B1 squared plus B2 squared plus B3 squared will be this, multiplied by D1 squared plus D2 squared plus D3 squared will be this. So you get your answer to be simplifying this as cos inverse of 0, which is cos inverse of 0 is, we know that it's equal to pi by 2. Therefore, the two straight lines are perpendicular. Let's see the next example, example 6.31. Show that the straight line passing through the points A, 6, 7, 5 and point B, 8, 10 and 6 is perpendicular to the straight line passing through the points C, 10, 2, minus 5 and D, which is 8, 3 and minus 4. So you have given two lines. The first line passes through AB and the second line passes through C and D. We need to prove that they are perpendicular. So to find the vector which is parallel to AB, if you subtract x2 minus x1, which is 8 minus 6 and 10 minus 7, 6 minus 5, the resultant, if you form a vector, that vector would be parallel to this line which passes through this. Similarly, for CD, applying the same principle, you would find the vector which is parallel to the line CD for getting the differences between the x, y, z of each coordinates. So our solution would be the straight line passing through the points 6, 7, 5 and 8, 10 and 6 is parallel to the vector, which is, subtracting, you get 2i cap plus 3j cap plus k cap. And the straight line passing through C and D. C and D is parallel to the vector, which is again subtracting these two values, you will find minus 2i cap plus j cap plus k cap. Therefore, the angle between the two straight lines is given as the angle between B and D. So the angle between the two straight lines is the same as the angle between B and D. So if we find the dot product of B and D, you get that to be as 0. How's that? B1 D1 plus B2 D2 plus B3 D3 will be equal to 2 times minus 2 plus 3 times 1 plus 1 times 1, which is equal to minus 4 plus 3 plus 1, which is equal to 0. So here you see that this is equal to 0. Therefore, the two vectors are perpendicular and hence the two straight lines are also perpendicular. Example 6.32. Show that the lines x minus 1 by 4, 2 minus y by 6 equal to z minus 4 by 12 and the equation x minus 3 by minus 2 is equal to y minus 3 by 3 is equal to 5 minus z by 6 are parallel. We have to show that these two lines are parallel. To show that these two lines are parallel, if we find the vectors which are parallel to these two lines, then we can, using those two vectors, prove whether these two lines are parallel. Now 4 minus 6, I'm taking minus 6 because it's 2 minus y. So 4 minus 6 and 12 can be the direction ratio or a direction ratio of a vector which is parallel to this line here. So let's define 4 minus 6 plus 12 as a vector which is parallel to this first line. Similarly, in the second line, minus 2, 3 and minus 6 because it's 5 minus z, so this is minus 6. So minus 2, 3 and minus 6 will be a direction ratio of a vector which is parallel to this line. So we have minus 2 I cap plus 3 j cap minus 6 k cap as a vector which is parallel to the second line which is given here. Now you can see in observing these two vectors that if I multiply this vector with a minus 2, so minus 2 times minus 2 will be plus 4, 3 times minus 2 will be minus 6, minus 6 into minus 2 will be plus 12. So this vector is a multiple of this vector. So since 4 I cap minus 6 j cap plus 12 k cap is equal to minus 2 times this vector here, the two vectors are parallel and hence the two straight lines are parallel, hence our proof. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.